Alright, so here we go. The real numbers. And this is every number that you've ever seen thus far has been a real number. If ever you're asked what kind of number this is, as long as it doesn't have an I with it somewhere, it's a real number. Okay? They consist of the irrational numbers, which those are numbers that are decimals. They never terminate and they don't repeat. Okay? Pi and non-perfect square roots. Does anybody tell me what a non-perfect square root is? So square root of 4 is what? Square root of 9 is what? Square root of 2 is what? That is a non-perfect square root. Okay, square root of 2 is an irrational number. So if you can take the square root of a number and you come back with another whole number, a whole number, then it is a perfect square. Anything else is non-perfect. So rational numbers are in decimal form and they either terminate or they repeat. And you can always write them as a fraction. Okay? So here it all is on this. We won't go through. Here's your examples of these things. Integers, negative numbers, 0, 1, 2, and 3. Whole numbers, 0, 1, 2, 3, 4. And natural numbers, 1, 2, 3, 4, 5. So whenever you're asked on this work, what kind of number is this? Generally, it's a good thing to do is to start with the natural numbers and say, is it a natural number? If it's bigger than 1, then it's a natural number. So if it's a natural number, it's also a whole number. Okay? If it's a whole number, it's also an integer. If it's an integer, it's also rational. Well, that's not necessarily the case. Integer, but it's also a real number. Okay? So go through and say, is it natural, is it whole, is it an integer, and then tell me what they are. So this is what we're going to call these numbers down here on the bottom. We're going to organize them. So the irrational numbers, we're going to call that particular set, we're going to call it I for the irrational numbers. So here's a few examples of what an irrational number is. You've got pi, you've got the square root of 2, square root of 5, square root of 72, and then you've got the number e as well. That's one of my favorite numbers, is e. So if you put it in your calculator and it's just a big string of numbers that never repeat and they don't terminate, then it's a pretty good indication that it's an irrational number. I think your calculators only go to 9 or 10 decimal spots. So if you don't see any repetition within that, just go ahead and say, hey, it's an irrational number. So the rational numbers, those are fractions, all right? And we'll call that set Q. Some examples of that are 0.34. See how it terminates, it just stops, okay? If it were kept going 1, 2, 8, 9, 42, 11, then it would be an irrational number. But where this thing stops, it's a rational number. And we've got 1 and 5/8. That is rational. 0.2. Anybody remember what that line above that 2 means? Repeats. And then -7/11. Alright, so integers we'll call z. And those are all numbers including like negative numbers, -1, -2, -3, and 0, 1, 2, 3. Here's your example of your integers. -7, negative square root of 100. Now it looks pretty weird, doesn't it? Negative square root of 100, but if you simplify that down, what does it become? -10. Take the square root of it first. Square root of 100 is 10. Throw that negative in front of it, -10. you'll see whenever we start practicing with these here in a minute that some of these numbers look kind of weird. Like take number 6 for example, negative square root of 81. Now, that's almost exactly like what we just did up here. Okay, looking at it, you see that square root and you'll automatically think, ooh, irrational and real. I'm done. But is that necessarily the case? You got to think about it a little bit. What kind of number is that? What does it simplify down to first? Negative 9. Alright, so we've got negative 9 now. Let's go back up here and look and see what we got. Negative 9. Is negative 9 a natural number? Is negative 9 a whole number? Is negative 9 an integer? Yes. Alright, so let's write that one down. That is an integer, so we'll say that is in set Z. So, is it a rational number? Can it be written in the form of a fraction? Negative 9 is the same thing as negative 9 over 1, is it not? Okay, so it's rational as well. And we'll say that that is in set Q. Now, since we've already did our little check here to see what's going on, negative 9 over 1, that's rational. It's technically a decimal, and it terminates. Okay, so it is not an irrational number, but it is, since all of these down here are real numbers, it's also a real number. Okay. And then here's another example of an integer, 8 over 4. Alright, so whole numbers. We'll call that set W. And here we go with your examples. Whole numbers start with 0. Okay? And then they go up from there. They get bigger from there. So 20 over 4. And I'm giving you these like this in this fraction form to let you see that numbers might look a little bit different, but if you think about them and try to do what we're doing and put them in some sort of a set, an order, so we can name them, if you simplify that 20 over 4 down, it becomes 5. Okay, so it's a whole number. It's also a natural number. It's also an integer. It's rational and it's real. Okay, but these are just examples of what these things can look like when they come at you. So square root of 16 and 90 is a whole number. And the natural numbers, we'll call that n. (10, 47, square root of 9, 34 over 2. Alright, so like we've been saying, we'll call the real numbers R, okay? And then let's see if we can organize this stuff here in this. This is a Venn diagram. Is everybody familiar with what a Venn diagram is? It's just a visual way to see what's inside of the other and what belongs to something. Like this whole school could be thought of as a set, right? The set of students in Union High School. And now there are subsets of classrooms, right? So my class is a subset of the high school. And Mr. Freeman's class is another subset. And that's all that we're doing here. Like the real numbers are like the high school. They encompass everything, right? So these other little circles are where everything's at. So we'll put I over here. That's the irrational numbers, because if it's irrational, it can only other thing that it can be is a real number. Okay, but once you get over into this part of it, the Venn diagram, like what we've been doing here, if it's a natural number, it's part of everything that's in here. Okay, so the natural numbers, and then if you've got your whole numbers, and then you've got your integers, and then you've got your rational numbers. And whenever I was in high school, whenever I furthered my math career in college, I had wished that my teachers would have been, and nothing against my teachers, they were wonderful teachers, but I had wished then that they had insisted on us calling numbers by their actual, like, names, right? Like irrational or numbers or integers or whole numbers. So whenever we're talking about these things, we're all going to try to get in the habit of talking about them as to what set that they're in, okay? If I'm talking about integers, then you all know that if I talk about just the integers, what's excluded from the integers? That's what you need to think about. What's not part of that set? Okay. So here's the integers. So if I say integers, then you can talk about whole numbers and natural numbers. You can use all that. What we don't want, if I say integers, is rational numbers or irrational numbers. Okay. So once we start talking about one particular set, everything above it is excluded. Okay. So let's practice a little bit on what these are called. Does anybody have any questions first about where we are? Okay. You don't have to write this part down, but I'm going to throw it in there anyway. But like the real numbers here, part of our unit and what we're going to end up going over, be still you, is complex numbers, okay? So the complex set, complex numbers encompass the real numbers and everything. So if it's any kind of number, it's also a complex number. And we'll get into that a little bit later, but just know that it doesn't stop with the real numbers. And it doesn't even stop with the complex numbers. It keeps going on with different kinds of numbers. And the math to do those is pretty wild. So let's practice this a little bit. Negative 10. Tell me every single set that that number belongs to. So is it a natural number? No. Is it a whole number? Is negative 10 in this set? Whole numbers start with 0. So no. So is it an integer? Yes. So let's write down Z. Alright. So if it's an integer, is it a rational number as well? Can we represent negative 10 some other way? We can. Negative 10 over 1, and that's rational. So Q, oh my gosh. So if it's rational, it's not irrational. They can't be in the same set like that. So we've got those two, so that's definitely a real number. That real part is something that you can go ahead and do. Every single one of these numbers on this front page are real numbers. Alright, so that's part of it done for you. Now what I'm going to do, I'm going to be quiet for a little while. I'm going to let you all practice on these things. And you can talk to your buddies and figure these things out. But go through and ask yourself, is it a natural number? Is it a whole number? Is it an integer? And if it is, write that letter for that set down. Okay?